let's do this. Alright, so I'm going to try to give this a little bit better understanding. Guys, a little bit better understanding on this arithmetic versus geometric. Arithmetic means I'm adding up. So let's take a look at an arithmetic formula. That would be like 8, and then let's say we go up.
16. It stopped.
Okay.
No, I'm just kidding.
16.
Alright, and then, no.
12.
Oh my goodness, you're killing me.
No, I'm making a sequence of numbers. You're just doing your own thing.
Alright.
Yeah, that doesn't make sense.
What do you mean?
I'm just like,
Alright, so this one goes up by 5 each time, right? So we're adding 5 every time. Does that make sense?
Yeah.
Since we're adding 5 every time, then this is what's called an arithmetic sequence. Okay? This one doesn't go up by the same amount each time. So now we want to see, is it geometric? It's geometric if it's being multiplied each time, right?
right?
And when we think about this, there's a couple of numbers that actually stick in my mind here. And that's 25 and 125. And then I'm like, well, wait a minute. Well, that kind of matches because that's 5. So if it goes 5, 25, 125, then it's really 5 plus 2, 25 plus 2, and 125 plus 2. So we're saying there's 5 times 5 times 5. So you get to the next number, I'm going to multiply it by 5. Does that make sense? So I'm going to 5 squared, 5 to the first power, 5 to the second power, 5 to the third power. Does that make sense? So I'm multiplying by 5s each time. Okay? So in this sequence, it is geometric. It's not, I know I was real sick last week and I said it was recursive. Recursive is when we're adding or multiplying the last number, right? So, you know, sorry, sometimes people are sick. So, arithmetic, we're adding each time. Geometric means we're multiplying numbers to get to the next number. Now, once I know that it's geometric versus arithmetic, now it's about, can I come up with a formula? So I'm going to come up with a formula for both of them. Just so you get an understanding of how would you come up with this formula? Find at u of 16 or find u of n. And so the way I look at this is I always start with the first, I kind of go, hey, if this one's x, right, how do I get to the next one? Is I add 5, right? And so x is the number I'm plugging in. So this is 1, 2, 3, 4, and so forth, right? So this is our first term, right? So 1, when I plug in a 1 for x, right? So how many times x plus what is going to get me the 8, right? And so I'm like, well, what am I adding up every single time? I'm adding up 5s, right? So I can actually have 5x right here. That this 5 is really a 5x. So that's how many 5s I'm going to have. In this case, I have 1 5. In this case, I'll have 2 5s. In this case, I'll have 3 5s, and so forth, right? And so then I'm like, well, if I have 1 5 here, how do I get to 8 from 1 5? So what do I add the 5 to get to 8? What do I add to 5 to get to 8? 3, right? So then I come, okay, well, 5 plus 3, right? So now I'm like, okay, I'm a little bit closer. 1 times 5, right? 1 times 5 plus 3 is 8. So what's 2 times 5? 10. Plus 3 is 13, right? And so does it keep working? What's what's 3 times 5? 15 plus 3 is 18, right? And so now I just found my n. I actually found u of n is really f of n is equal to what? 5n plus 3. Does that make sense? That's my formula to find any value. And then they said, well, we want to find the value of 16. So how would we find the value of 16? We would say f of 16 would equal 5 times 16 plus 3. And 5 times 16, well, that's 50 plus 30, right? And so that's 80 plus 3, so that's 83, right? So f of 16 is equal to 83. So the 16th term should be 83. Does that make sense?
Yeah.
Right? If this was arithmetic. But they asked us to find this geometric. You go about it the same way. Okay? Except instead of saying that I got 5 x's, right? In this case, I'm going to have 5.
It's 1, 7, 27, 27.
I know, but I made a mistake on that when I wrote that. On the first test, it was a 1, and I forgot to change the 1 on that, so that's my fault. So it should be 3, 7, 27, and 127. And you'll see why in a minute. This one's kind of harder because when I go to 5 to the x, and in this case, I'm going to say I have this many 5s, right? Now remember what I said. This one was our first one. This is our second one. This is our third one. And this is our fourth one, right? But this is really 5 plus 2. Right? So this is really 5 to the first power. Really? Okay, can you get back to this real quick? Alright. So this one, it gets a little confusing. Right? So you have 5 to what power? And in the second one, it's actually 5 to the 1. Right? So when I'm looking at this, when I'm looking at 3, 7, 27, 27, and 127, I'm seeing that here is 5 to the 1, 5 to the 2. But this isn't the first term, is it? This is the second term. So how do I go from the second term to the first term? How do I go from the third term to the second term? How do I go from the fourth term to the third term? Does anyone see a pattern happening there? Come on. How do you get from 2 to 1?
1.
So how you subtract 1, right? If I subtract 1 from 2, I get 1. If I subtract 1 from 3, I get 2. So this is where we get the x minus 1, right? So if I took x minus 1, then in the very beginning, what's 1 minus 1? 0. What's 5 to the 0?
0.
No. No. 5 to the 0? 1. So 1 plus 1 is 3. Plus 2, right? See how that works? So we have 5 to the 0 plus 2. We have 5 to the 1 plus 2. We have 5 to the 2 plus 2. So 25 plus 2, right? It's 27. We have 5 to the 3 plus 2 to get 127, right? So what's happening here is we really have 5x to the x minus 1 plus 2. So we have to add 2 to that. So now we know that f of x is actually equal to 5 to the x minus 1, and then down here plus 2. And this is how I realized that after I turned the camera off, I go, well, wait a minute, that can't be recursive. Because if I can put in a formula, you can't put a recursive function in a formula. right? You'd have to use summation. And I said that right at the beginning. Oh yeah, we can write this in a summation or in a productation. And then I solved it in a formula and I'm thinking, right after I turned the camera off, wait a minute. That's not recursive, that's geometric, right? So when it multiplies, it multiplies, it multiplies, it multiplies, and then it becomes an exponent. Your variable becomes an exponent instead of being an additive addition being multiplied by, okay? So if that's the case, then all I have to do to figure out what the formula is plug in f of 16 equals 5 to the 16 minus 1 plus 2. And then when you do that, it's a really, really big number. So big that our calculators actually don't get an accurate feel for it. But 5
Oh, I'm gonna go change.
to the 15 plus 2 is, oops, that didn't work out. Oh, it's still there. Okay. Hopefully. So it looks like f of 16 is equal to 3.051757813 times 10 to the 10th power. That means it's 10 decimals over. So yeah, kind of crazy. I think it rounded off. We just didn't have enough decimals on the calculator. You kind of need to do this one on the computer. The computer will give you a lot more decimals. I think it can go to 29 decimals and then you'd be able to solve it. But the idea is this. The idea is this. I want to make sure that you know how to get to here. Okay? And that you can get to here. Cool? So that's two ways of doing it. Arithmetic, geometric. Neither of which are recursive. Does that make it easier? Hopefully. Yes, sir. That is correct.